tell us about machine learning and dynamics supply chains, logistics perspective. Please.
Thank you, Martina. And thank you, everybody here at Digital Futures, for inviting me to this session. Thank you for the introduction. Yes, I'm an assistant professor at the Department of Production Engineering here at KTH. And I work mostly in the area of logistics. So I guess the purpose of my talk today will be the implications of one of the technologies that is transforming the movement of materials and information in factories, machine learning. And I think there's a lot of questions about how to use this technology, where to apply it, and to what purpose to do so. So I will present some insight as to what is being done in this field. And then I will provide some examples of the cases that we're working with together with the industry and also in our lab. So with that being said, then I can like to tell you about the agenda that I've prepared for today. First, I would like to set up the context of my talk and define some of the key terms that I will be discussing today. Then I will describe why is it that we apply this technology in the context of logistics and some of the associated enablers that we need. Then we will jump into the examples both that exist in general and in our research field. And I will not be talking for the entire hour. I think I would like more to have some sort of a question answer at the end of the session. A brief background on our field in our department. As I said, I work for the Department of Production Engineering, and we go from the moment that we have instruments touching a material, how these are measured or machined, the process of assembly. We have a lot of colleagues working in circularity these days, human-robot systems, production management that has a lot to do with lean production, and then finally us, the research group in production and logistics. Now, while the work that you see my face today in this conversation, but I would like to highlight that this is a collaborative work with several of the colleagues in the research group, and I cannot take credit for all of what I am presenting here today. Right, so then setting up the context. What is it that we mean when we talk about a supply chain? And I suppose that we hear this word a lot here and there. I think it's very common, especially now that we have heard a lot about taxes and trade and, tolls and this sort of things, disruptions into how material is transported in different industries. So when we talk about a supply chain, we mean that we are coordinating and planning mostly the transfer of raw materials or finished goods from one point to another. And this requires an enormous effort, both in terms of money and resources, usually across the world. And because this requires a lot of transfer of information and materials, and it does so across continents, then this setup of a supply chain is very sensitive to disruptions. And what I mean by that is that it can be, for example, weather conditions, it can be political circumstances, it can be missing material or problems with quality. So I think we've seen a lot of examples recently. If you remember, for example, the Suez Canal, war conflicts that have arisen recently, and so on. Now, when we talk about this supply chains, I think a critical aspect here is that we both coordinate how we send things and how we receive them, but also how we collaborate with partners. And so then establishing good communication and critical information across this supply chains is decisive. Now, if we zoom into the area of supply chain, then one aspect of this involves production logistics, which is the field that we work with in our research group. And by that, we mean the movement of information and materials inside a factory, inside the fence of a factory. And this specifically has to do with, for example, picking material or packaging or putting it in a warehouse or pushing things around in a factory and so on. And if we think about this, it might seem like a limited aspect of what is done, but in factories, in the industry, but actually it's not. It's quite the opposite. Movement of materials and information is the number one activity that factories do. And this might sound a little bit counterintuitive. If we think about that pushing things around is the number one process, many times what we pay for in a factory is pushing air, for example, pushing empty boxes, pushing scrap, pushing pallets, moving things around. So if all things considered, when it comes to the movement of materials and information, it accounts for nearly half of the cost of factories. It employs a lot of people as well. More than half of the space of a factory is only logistics. And nearly 90% of the time is pushing things around. So you can imagine all the enormous costs that this implies. Now, I would like to add that this challenge is increasing, especially for high-cost countries like Sweden. What do I mean by that? Sweden or Swedish manufacturing is not very likely to open new factories, not very likely to increase the size of its factories. So this means that on the one hand, the customers of Swedish manufacturing, they're asking for more and more products, more diverse products, a greater variety in more distinct volumes. But at the same time, we cannot increase the size of our factories. So this means that we need to use much better space than we are currently doing. And this presents a problem for logistics. That being said, then there's a lot of discussions as to why digitalize production logistics. And I guess one answer to this would be because it's fun to put sensors and robots in places. But I guess another perspective on this is because there's an increasing need on improving sustainability. Swedish manufacturing is a big contributor to CO2 emissions. It is also employing a lot of the population in Sweden, both directly and indirectly. So, of course, the well-being of workers in factories is important. It's important for employability. So what we try to do then is that we try to provide tools when it comes to the movement of materials and information and try to impact both the economic, environmental, and social sustainability. So what is it that we try to do then when we talk about digitalization? Well, first of all, we try to focus on how and what are we moving. So it could be, for example, picking things in a warehouse, how we plan to deliver material, the way that we package things to be sent to customers, or how we are transferring products from one place to another. And in this context, then there are different information needs. Sometimes we need to generate information. That is one of the first challenges, knowing where things are, for example. And once we achieve this, then the second step is trying to process the information that is coming out from sensors or cameras or etc. And then finally, the third step is using this information, trying to affect the factory environment to improve its conditions. And this can mean many things. It can be, for example, reducing cost or time. Maybe it has implications into sustainability or CO2 emissions. Maybe it has an impact on picking the right products to be sent to customers. For example, if you've ever ordered something online and what you received is not what you expected or not in the quality that you expected or the color or quantity, well, this is a logistics quality problem. That we can respond to changes as well. For example, that we can account to changes of season. If we think about, for example, if we are making or setting up the demand for delivering clothes in a winter season, that we have the right quantity that will match the demand. And of course, human-centered aspects. Are we taking good care of people who are working in this area? We have a number of technologies that we apply in these cases, in this story that I'm describing, both to generate information, to process it, and to use it. And in relation to the subject of my talk today, when it comes to machine learning, we see more and more that this is being used to process information and to use it. And I will try to give some examples of what I mean by this. Now, I think what I would like to point out is that the area of logistics is an area that is, I wouldn't say that it's at the forefront of using machine learning or developing machine learning, but instead it's a runner-up. And just like many other areas of our daily life that are using artificial intelligence or in particular machine learning, then we have these spin-offs that are impacting logistics. And I think you're all familiar, perhaps even more so than I, when it comes to using different types of applications that help us with our everyday tasks. And this is some sort of exemplification of what we are also seeing in a logistics context. There is a reason why machine learning is so critical nowadays when it comes to logistics. On the one hand, logistics it generates a lot of information, big data sets of the quality of, for example, the products that we have. Where have they been? In what conditions have they been? How they have been stored? Or where have we sent these things? So this enables us to capture certain features of these products and try to understand, okay, what are the salient variables? What are the salient decisions that I could interpret in order to produce a desired effect? And when we do so, then we can start to think about certain recommendations that we can provide to make an improvement. Now, this is important because, unfortunately, much of what we do currently in the industry is based on experience of engineers or operators that have been working in the factory for a long time. And perhaps in the past, this was sufficient if we think about factories that made one or two products. But nowadays, if we think about the thousands of products that need to be made, it's extremely difficult, or I would say impossible for a human being to really understand the depth or the context or the trends that are arising. So by applying then machine learning, we can predict unknown values. We're using machine learning in four aspects, I would say. when it comes to logistics. Much of what we try to do is to understand the disruptions of an environment. So if we are able to, for example, pick up trends that are repetitive, when are they presenting? In what magnitude are they being presented? Are they affecting all of our products or just some of them? This is a critical aspect so that we can start to account or prepare for these events. We're also using it, as I've already suggested, on predicting. Okay, so what if a certain pattern would arise, then what would be the best decision to make? How is it that I'm going to ship things to my customers, for example? And associated to this, I would say that what we also see is that there's 5 critical technologies without which we could not apply machine learning in a context of production logistics. And to achieve this, then, the first step is that we need to scan our environment. We really need to acquire data. And this can be sensors or cameras or real-time location systems, etc. We need to store this information in databases and perhaps conduct some processing and transformation of this data. We need the algorithms in order to teach certain behaviors and to learn them. And also, many times, we need to execute the decision that we're trying to apply. And this can be, for example, a model, it can be a robot, it can be some sort of an application or a service. But I think I've been talking very general right now, and I would like to situate this talk into examples that we have together with the industry in different research projects. I would like to say or highlight that this is a field that is attracting a lot of interest from the manufacturing industry, and we've been very lucky in bringing in projects together with the industry at different levels of this story. Some of the needs have had to do with where is the material, trying to visualize or let's say locate where material is. And that would apply to this type of projects here that I'm highlighting with the pointer. Then we have a number of projects that have to do with, okay, so once we have acquired this information, then how do we process the data? And then finally, how is it that we present this information to different types of users? It can be people, it can be machines, it can be services or systems. This is an example of one way in which we are applying vision systems in the area of logistics. And I guess we focus lately a lot on trying to recognize posture of human beings because of all the people that are employed in this area. And we could think about this, for example, with a very simple example. If you've ever been to, or when you go grocery shopping and you buy or go around the store to pick up things and so on. Well, all this putting things in a cart, pushing it, etc. Many of these things are extremely unergonomic and very repetitive. So of course, creating an impact as far as, for example, ergonomics or time, really matter in this field. Another way in which it has been used, this type of systems in our research environment, is trying to communicate with assets, and not with a graphical user interface, but by having a certain posture of the body, for example, and then actuating a robot. And in this case, for example, my colleague Jake, he was raising his hand to call in our autonomous mobile robot. And so then when the robot comes to deliver a certain material, and this material has been delivered, then you can send it back to its position also with a gesture. Another extension of this would be that the recognition or the segmentation of manual tasks. And what we see, for example, is a cable harness assembly. This is, it looks like a water hose. It's very flexible. And it goes into cars. All vehicles need it. And because of the geometry of this type of products, it's very difficult for robots to manage this. So it requires manual tasks from operators. But in order to improve this type of work, then it's critical to define when and how and what is it that people are doing. And traditionally, this has been used with timing devices, with a clock, paper and a pencil, and so on. But this is obviously very time-consuming to do it manually. So instead, vision systems can be applied to automate this sort of tasks. So this was a prototype together with Scania in a project. Also, many times when it comes to the area of logistics, we need to pack material or we need to unpack material. And this means that on the one hand, we need to identify what type of product we're talking about, also the quantity of the product or where a product is located. And especially if we want a robot to help us, for example, lift a part. And so in this sense, the use of vision systems is also very important. Then finally, the last example that I would like to give it has to do with human order picking. And what you see here to the right is an example of this activity, which we call human order picking in warehouses. While what you're seeing is from the automotive industry, this happens a lot in all types of industries, especially when you need to ship products to the customer. And you see it, for example, in Amazon warehouses, or you see it in Sellpy, or you see it in food, or you see it even in supermarkets. And basically what you're asked is you have a list of things that you need to pick. You manually go through aisles and pick these parts, put them in a cart. And once you have stashed all things in your list, then you push your cart to its final destination and it gets delivered to either a customer or a station or etc. Now, let's think about the people who work in this area. Sometimes they're tall, sometimes they're short, sometimes they weigh over a certain number of kilos, sometimes under a certain number of kilos. Sometimes these people have been working in the warehouse for many years and they know it very well. Sometimes they have been working only in the summer for a couple of weeks. And then finding your way around the warehouse is very complicated. Most of the people, at least in Sweden, who work in this area are not native Swedes. Most of the people come from other languages, other backgrounds, and they need to interpret the information that is presented to them in Swedish to go and pick this material. Now, when you go and pick a material, the information is usually a very large code. And it's, a set of numbers and letters that might be 10, 12 characters. Now imagine yourselves, it's a Friday, you're tired, it's the end of the shift, you're really looking forward to the weekend, it's really nice and sunny outside, and you've been doing this for 8 hours. It's very easy to make a mistake. It's very easy to make a mistake after lunch. It's very easy to make a mistake at the end of the shift. Now, let's imagine that you're sending the wrong part that is going to be assembled in a car. Well, it's very likely that we will have an accident there. So what we try to do is we try to use different types of digital technologies to help operators in this area and improve their working conditions. So to that extent, we built a prototype in our lab of that represents this picking activities. So we have a picking app that presents information to operators, and then we go around and pick materials that are located in different parts. And what we do then is that we have a vision system that is collecting information on how is it that we are moving around and the type of activities that we are doing. Now, this is important because on the basis of time, then we can establish whether one of these activities is taking us a longer time. And this presents an indication that there is a problem. For example, if we see that in our data set, the activity of searching is taking a long time, well, this probably means that the operator is having a hard time locating a part. And this can be because the information is presented in a wrong way, because I have not been trained, because the products have been changed in their arrangement, because it's the first time that I'm in this aisle. Very simple example or an analogy of this case that I'm describing. Perhaps you've been to your local grocery store, and I think that if your local grocery store is similar to mine, every now and then they change the aisles. And every now and then I'm really trying to look for coffee and I have no idea where this is. Well, this is a similar type of situation. Now, with the exception that unlike you and I, who have all the time in the world to find our coffee, these people are working with a clock that is ticking down. And they need to deliver their part before the clock hits the 0 mark. Now, I don't know about you, but I get very stressed when I see a clock that is ticking down. And when I'm stressed, I make mistakes. And these mistakes can mean that I pick the wrong things, but also that I can injure myself or make all sorts of errors when I'm doing this. So this is, I guess, some of the examples of how is it that we can use this technology to improve the working conditions of people in a warehouse. And with that, I would like to end my talk. This is my contact information in case you're wondering about the potential collaboration or you would like to continue our discussion. But I would like to open up to questions that you may have.
Thank you, Erik.